Hi, Chris Kuzmal here. We are working on the counting sort. We have completed the histogram and scan methods and their tests, and we've created a test for placement and created a stub for placement. Now we're going to endeavor to implement placement and hopefully have that placement pass the one test that we have running, we have expected. So let's go ahead and move this screen to a slightly more awesome size. And we're going to I'm just going to crib some Corman Lysis in reverse code. And what they do is they write for J and equals length of A. And this is, don't think this is Java code, okay? Down to 1, oh my God. And then what they have inside of that is this horrible code, B of C of A of J, okay, is set equal to A of J. All right. And what happened? I hit some button. Now I've unhit it. And then they do C of A of J, okay, becomes equal to C of A of J minus 1. And this is pretty scary code. It's just, and look at this. Look at line 26. B of C of A of J. I mean, who knows what that means? God only knows. And I'm not going to do a huge improvement on this, but at least I have naming for C. Okay, C is our address, sort of. So we're going to replace C with address in our code. Okay, and we start to see almost immediately that we change the address, we decrement the address, we decrement where we're going to be putting things by 1 on each iteration. Line 27 is going to be executed, and this just reduces the size of the value of address at the location A of J by 1. Okay, so this line of code, line 27, is a little bit more understandable. I wish I could give you a more coherent explanation of what A of J is. It's important to understand that A is an array of integers that are going to be sorted, okay, and B is our, oh my goodness, did I make a mistake? No, well, no, I don't think I did. But what is B? Okay, B is our output. Okay, B is the return value, and the final sorted result will be retval. So retval at a location given by the input array at a given location J. Now we know we can almost read off line 26 in a sensible way. Honestly, we can't quite. I still would like to write this code even more clearly. But at least line 26 and now line 27, simply by changing the names, they're a little less cryptic. I would say they're still pretty dense. And now, of course, we need to modify this loop for J equals length of A. So I'm going to go ahead and stick with J as being the variable name. I'm not in love with it at all, but J equals length of A. Remember what was A? A is still A, but we're going to uncapitalize this. And the way we get the length of A in Java is we do A dot length. Okay. Now the problem is that that's going to give us an index out of bounds error in Java because we're zero-based indexing. So we're going to subtract 1, okay, and then J is, we're going to assume that we're going to go all the way down to J equal to 0. So as long as J is greater than or equal to 0, and then the down 2 is going to, it corresponds to J being decremented. Okay, so this is a translation of that Corman-Liserson and Revest pseudocode. Okay, and of course I'm going to put curly braces. Oh my God, I am not pleased with my editor's assist function. So I put these curly braces around these two lines, lines 26 and 27, that are inside this for loop. And so now J simply begins at the end of our array. So let's take a quick look at our placement test here. We are going to be starting at the end of the array A. Okay, is that really right? Because I'm expecting to be wanting to look at the expected scan output. I'm expecting to look at address. But maybe this is right. Because so if we're starting at the end of the array A, so we look at the end of the array. Oh, that's right. So this is a little subtle. We're actually the key thing. If we look here on line 12 in this example for the placement test, we're wanting to place the value 1 of AR into the correct place in retval. That's what we're trying to do. Okay, and that means we begin by looking at that guy and saying that's a 1. Okay, that 1 corresponds to a index into the expected scan output, or the scan output, and that's going to be here. And what's that? And what that is saying is that the location of the last value equal to 1 should be at index 2. And so that is exactly where we're going to place it by putting, so that's what this then becomes, address. That's location 2 in the return value is set equal to the A of J. And then all we do is we reduce the size of the address by 1, okay, and then go and look at the next smaller value in the input array. And that actually then we then look at location 4 in the scan output 0, 1, 2, 3, 4, and the 4 it indeed belongs at the very end, and so it gets placed at location 4. That slightly concerns me because a 4 is going to be an index out of bounds error, isn't it? Indeed, it is. So my suspicion is that we're going to get an index out of bounds error when we run this code. Let's see what happens. Now that I've sort of explained and thought about it, I could be doing a misanalysis here. I've done a direct translation, but I am concerned we will have an index out of bounds. We may need to subtract 1 from everything in the scan output. Let's find out. Got to be careful not to overthink these things. Okay. Oh God, I need to restore that. Okay, I think I was clicking on the wrong thing. There's my restore button. And we kind of run. I'm expecting an index out of bounds error. We do get an index out of bounds error, the 4 that I expected. So I'm going to need to think, as should you, about why we're getting an index out of bounds error. It looks like the input value is wrong in its way. And so we're looking at potentially a mismatch between the way Java behaves with 0-based indexing and the way Corman-Liserson and Revest expect things to behave with 1-based indexing. So we'll see. I'll think about it, and then I'll come back and we'll talk about it.